Hi everyone, my name is Kyle Roberts and I'm a Senior Technical Marketing Engineer with F5's Security and Distributed Cloud Group. Today we are going to demonstrate F5's Distributed Cloud Bot Defense Service. As digital transformation continues to drive cloud adoption, the innovation and growth of application architectures is changing at an unprecedented pace. A consequence of these evolving applications is increasing complexity and risk. Ensuring that applications are protected, regardless of where they're deployed, becomes an increasing challenge. At the same speed that applications are evolving, so is the sophistication of tools in the attacker's tool belt. Many of these attacks lead to fraud and other damaging results to the business. From credential stuffing using stolen credentials from the latest data breach, to financial aggregators creating unintended risks for the financial institutions and the consumers. The use cases for a robust anti-automation solution have never been stronger. Now let's take a preview at the demo environment that we'll be showing today and briefly discuss the components. Everything today is configured in F5 Distributed Cloud Services, which provides SaaS-based security, networking, and application management services that can be deployed across multi-cloud, on-prem, and edge locations. Our demo application is deployed in a virtual Kubernetes cluster running within the Distributed Cloud app stack. Distributed Cloud Bot Defense leverages JavaScript to collect client signals and determine if the client is human or automated. We'll look at the JavaScript injection component in more detail. When it comes to simulating real automated attacks for our demo, we are using Selenium with Python to instruct the Chrome browser how to perform our attack. Inside the Distributed Cloud Console, let's start by navigating to the billing menu to ensure that we are using the required organization plan for bot defense. If not, we need to switch to this plan and select the Bot Defense add-on service. This will initiate a ticket to F5 and generate an email confirmation back to the user. Once completed, the Bot Defense service will be available for configuration. Now let's take a look at the web application that we're going to protect. In our example, we have an app running within a virtual Kubernetes cluster. If we browse to our distributed apps, virtual Kubernetes, we can check to make sure that the pod is up and running. Now let's take a quick look at the application and make sure it's up. Since we have pre-configured the container application as the origin behind the load balancer, the next step is to configure our bot defense. We can go to Manage, Load Balancers, and manage the configuration. Then we'll browse to the security configuration. By default, the bot defense setting is disabled. We need to change this option to specify our bot defense configuration. Next, we need to select our bot defense cloud region. In our case, let's pick the US. Now let's create our app endpoint policies and actions. Our first endpoint will protect the sign-in page, and the second will protect the payment page. We'll click Add New Item, give it a name of Sign-In, and set the description to Protect Sign-In. Let's specify the HTTP method to POST and the protocol to be both HTTP and HTTPS. For the domain matching, we'll leave it at any domain, but if you have multiple domains behind your load balancer, you should specify it here. For the path matching, we have three options: prefix, exact path, and regex. For our use case, we're going to use exact path of /user/signin. We have three options for mitigating action as well: flag, redirect, and block. Let's choose block for this sign-in policy. We'll also add a custom block message of OWASP OAT for automated threat, 008 credential stuffing attack blocked. I've gone ahead and created the second endpoint policy for our payment page, and the action specified is flag instead of block. We've defined a policy to protect the sign-in endpoint with prevention enabled, and another to protect payment in flagging mode to detect two different types of automated threats: credential stuffing against the login page, and card cracking or carding against the payment page. Now let's define the JavaScript injection settings. We've gone ahead and named our JavaScript mybotdefense.js, so it's easily identifiable for our demo. In production, something generic like common.js is a much better idea. For the sake of our demo, let's inject the JavaScript into all pages and specify after the head tag for our location. Now let's apply our config and inspect the code on our web app to confirm the JavaScript injection. If we expand the head tag on our page, we can see our mybotdefense.js JavaScript is being injected appropriately into our application. Now let's launch our first attack using Selenium against the user sign-in endpoint. As we launch the credential stuffing attack, we can see our block message that we have configured is now being displayed. This tells us that our credential stuffing attack is being blocked based on our policy. Let's move on to our second attack using Selenium again against the payment endpoint. Make note of the response page in flag-only mode. Payment attempts are actively being sent through to the origin, and eventually one of these will be successful. Now let's switch the mitigation action of our pay endpoint policy from flagging to blocking and relaunch our credit card attack. We can see that the message now being displayed shows us that the requested URL is being rejected based on our block policy of the pay endpoint. Let's navigate to the visibility dashboard for bot defense and take a look at the analytics we can get related to these automated attacks. We go to the service menu, and under Web App and API Protection, Apps and APIs, Security, let's select our load balancer from the load balancers list, and the security dashboard appears. From this centralized security dashboard, you can get insights into all of the other web app, API, DDoS, and bot security analytics. From the security dashboard, let's click on the Bot Defense tab. This dashboard presents key information like which bots are making the most malicious requests, which endpoints are attacked most, and which automation types are being used the most. You can customize the time period, filter results, and make other adjustments using the dashboard features available. Using the time window selector, we can see our attacks have been flagged as automation by the threat intelligence signals. Let's click on the Bot Traffic Overview tab. The Bot Traffic Overview dashboard provides detailed insight into traffic on the HTTP load balancer. In addition to the chart showing transactions per minute for a specified time window, you can also view details about every HTTP request seen by our bot defense. F5 Distributed Cloud Bot Defense is an advanced add-on security feature included in the first launch of the F5 Web Application and API Protection Service, with seamless integration to protect your web apps and APIs from a wide variety of attacks in real time. Thanks for watching, and we'll see you next time.